Okay, so we're diving into some pretty wild stuff today. Google's new Willow chip,
Ah,
and the whole future of quantum computing. Even Elon Musk is tweeting about it.
he is.
It's like this tech that could seriously change everything.
It really could, yeah. The potential is huge.
So for this deep dive, let's break down like what makes Willow so special and what it means for, all of us.
Sounds good. Yeah.
Can you give us like a crash course on what is quantum computing
Sure.
and why is everyone making such a big deal about it?
Yeah, so it's like a completely different way of processing information compared to like the computers we use every day,
Right.
our laptops and phones.
Yeah.
Instead of bits, which are either like a 0 or a 1,
Right.
quantum computers use these things called qubits.
Okay.
And these qubits can be 0, 1, or like both at the same time.
Whoa.
It's this weird thing called superposition.
Okay.
And this lets them like tackle problems that would take our best supercomputers, billions of years to solve.
Oh, wow. Okay, I'm starting to see why people are so excited about this.
Yeah.
So where does Willow fit in?
So Google says that Willow did this crazy complex calculation in under 5 minutes, something that would take a classical supercomputer 10 septillion years.
That's insane.
Yeah, it's a long time.
It is.
It's like longer than the universe has existed.
Yeah, what was Willow actually doing in those 5 minutes? Like, what problem was it solving?
Right. So it wasn't solving like a practical problem. It was more about showing off its raw power
Right.
through this thing called random circuit sampling.
Okay.
It's basically a benchmark to see how well a quantum computer can handle problems that are just impossible for classical computers.
So like a stress test.
Yeah, like pushing it to its limits to see what it can do.
Okay, so it's proving that it can handle a completely new class of problems.
Exactly.
Wow.
And another impressive thing is Willow's breakthrough in quantum error correction, which has been a big challenge in this field.
Right. I read that managing those errors in quantum computers is like a huge problem.
It is.
Why is that? And how did Willow actually overcome it?
It's like trying to build a house of cards in a windstorm.
Okay.
The more cards you add, the more unstable it gets.
Right.
Qubits are super sensitive, and the more you have, the more likely they are to have errors,
Right.
which can totally mess up a calculation.
So error correction is like finding a way to shield those cards from the wind.
Yeah, exactly. You can build a more complex structure that way.
Okay, I like that analogy.
What's remarkable is that Willow doesn't just correct errors.
Yeah.
It actually suppresses them as the system gets bigger,
Oh, wow.
which means we could potentially build like much larger and more powerful quantum computers
Okay.
without being held back by those errors.
Okay.
Willow is the first to operate below threshold, which means adding more qubits actually leads to fewer errors.
Okay.
And this has been like a goal for almost 30 years.
That is huge.
Oh.
It sounds like a complete game changer.
It is.
I did read about China's Zhaohong chip, which has way more qubits than Willow. So is it just a case of like the more qubits, the better?
Not always. While Zhaohong has almost 5 times the number of qubits, it doesn't have that same error correction ability. It's like, think of it this way. Zhaohong is a powerful engine, but it's like kind of rough around the edges, prone to sputtering.
Okay.
Whereas Willow is like this finely tuned machine that runs really smoothly.
So both chips have their strengths and weaknesses.
Right. That depends what you want to do with it.
Okay, so for the average person, though, what does all this actually mean? Like, how could Willow impact our everyday lives?
That's where things get really exciting. Let's start with medicine. Willow could simulate how molecules interact super fast and accurately.
Oh.
So scientists could design and test drugs virtually.
Wow.
Imagine treatments tailored to your specific genes.
That sounds incredible. What other areas could Willow change?
Climate modeling is another big one. By processing huge amounts of data, Willow could give us super accurate climate predictions.
So we could have a much clearer picture of, like, the future of our planet.
Exactly. And material science, too? Quantum simulations could lead to discovering brand new materials with properties we can't even imagine right now.
It sounds like we're talking about solving some of the world's biggest problems.
Yeah,
But it's easy to get caught up in the hype, right?
right.
So let's talk about limitations. Are there downsides or challenges that we need to be aware of?
Yeah, it's important to be realistic. While Willow is amazing, there's still a lot of work to be done.
What are some of the biggest obstacles?
Building and maintaining these quantum computers is super expensive and complex.
Okay.
We need specialized equipment, extremely low temperatures, and more experts who can actually program these machines.
Right.
So we're still in the early stages.
It sounds like it'll be a while before we all have quantum computers at home.
Yeah, probably.
But the potential benefits seem huge.
They are.
It's amazing how far we've come and how much potential there is.
It is an exciting time.
We've covered the basics of quantum computing, the awesomeness of Willow, and touched on some of the potential applications and challenges.
We have.
Now let's go deeper into those applications, starting with the one everyone's talking about. How Willow could completely revolutionize medicine.
Yeah, let's get into it.
Okay.
You know, when we talk about revolutionizing medicine, one of the areas with the most potential is drug discovery.
That's what I'm really curious about. I keep hearing how quantum computers could speed up the whole process,
Right.
but I'm not sure I get how it would actually work.
Sure. Yeah, so right now, drug discovery takes forever, and it's super expensive.
Yeah.
It involves testing tons and tons of molecules to see if they have the effect you want.
Okay.
It's kind of like trying to fit puzzle pieces together in the dark.
Oh, wow. That sounds really tedious.
Oh, it is. But with Willow, scientists could simulate how molecules interact at the atomic level.
Okay.
So, imagine designing and testing drugs virtually.
Yeah.
Yeah. You could see how they bind to proteins and predict how effective they'll be before you even set foot in a lab.
So instead of spending all that time in the lab, researchers could just run simulations on Willow and figure out which drug candidates are actually worth pursuing.
Exactly. It would seriously speed up the whole drug development process, maybe save years of research and millions of dollars. It's like turning on the lights in that puzzle room.
Yeah, that's a great analogy.
Mm.
Are there any specific diseases where Willow could make a difference right away?
Oh, yeah, absolutely. Take cancer, for example. Willow could help create personalized cancer treatments
Okay.
by simulating how different drugs would interact with the patient's tumor cells.
So instead of a one-size-fits-all approach,
Right.
we could have treatments that are tailored to each person's unique genes.
Exactly. Personalized medicine at its finest.
That's pretty amazing. Are there other ways Willow could change healthcare besides drug discovery?
Totally. Medical imaging is another area that could be disrupted. You know those quantum sensors that use quantum mechanics?
Yeah, I read a little bit about those.
They could lead to imaging techniques that are way more sensitive and precise.
How would they be better than the imaging technology we have now?
Imagine a brain scanner that's so sensitive it can pick up tiny changes in brain activity
Okay.
that could help diagnose conditions like Alzheimer's way earlier.
Oh, wow.
Or a heart monitor that could predict a heart attack before it even happens.
So not just improving diagnoses, but actually preventing diseases altogether.
Yeah, that's the goal. Shifting healthcare from reactive to proactive.
Okay. This is all pretty incredible.
Yeah.
But I got to ask about access. If these quantum computers are so expensive to build and maintain, how can we make sure everyone who needs these life-saving technologies can actually get them?
That's a really important question and something researchers and policymakers are trying to figure out. One solution is to develop software and interfaces that are more user-friendly.
So make it easier for people to use them, even if they don't have a PhD in quantum physics.
Right. The goal is to make this technology available to everyone, not just a select few.
Okay, that's good to hear. So we've talked about how Willow could revolutionize medicine through drug discovery and medical imaging. What other areas could see big changes because of quantum computing?
Climate modeling is another one where it could have a huge impact. Remember how Willow is really good at handling massive amounts of data?
Yeah, you mentioned that earlier.
Right. So even the climate models we have now, the ones running on supercomputers, they have a hard time simulating all the factors that affect our planet's climate.
Okay.
And that leads to uncertainty in the predictions, which makes it tough to anticipate and prepare for the effects of climate change.
So right now we're looking at a blurry picture of the future.
Yeah.
But quantum computers could give us a much clearer image.
Exactly. By processing tons of climate data, quantum computers could create much more accurate simulations.
Okay.
So we could understand how our climate is changing and predict future trends with much more certainty.
That would be a game changer for climate scientists and policymakers.
Mm.
Are there certain types of climate data that Willow would be especially good at analyzing?
Well, one example is ice sheet dynamics. Understanding how ice sheets are melting and contributing to rising sea levels.
Right.
That's really important for coastal communities everywhere.
Yeah.
Quantum computers could simulate those processes super accurately and give us really valuable insights for adaptation and mitigation strategies.
So it's not just about predicting global temperature increases.
Yeah.
It's about understanding the specific effects that directly impact people's lives.
Exactly. Quantum computing could give us a much deeper understanding of all the interconnected systems on our planet,
Right.
so we can make smarter decisions about how to protect our future.
It's amazing how technology could help us solve such a complex problem.
It is. And there are even more potential applications for quantum computing besides medicine and climate modeling.
Okay, now I'm really intrigued. What else can these quantum computers do?
Well, we've talked a lot about how Willow is great at dealing with huge amounts of data,
Right.
but quantum computers are also really good at solving optimization problems.
Okay.
Those are problems where you're trying to find the best solution out of like a ton of different options.
Can you give me an example of a real-world optimization problem that Willow could help solve?
Sure, imagine you're running a logistics company with a fleet of delivery trucks.
Okay.
You need to figure out the most efficient routes for all your drivers, right?
Yeah.
Taking into account traffic delivery deadlines, fuel efficiency, all that stuff.
Sounds complicated.
It is. It's a super complex optimization problem with tons of possible solutions.
Yeah, I can imagine. It would take forever to calculate all those routes manually.
Exactly. Even traditional computers can struggle with these kinds of problems. But a quantum algorithm designed to run on a computer like Willow could potentially solve it much faster.
So that would be huge for any company dealing with logistics.
Absolutely.
Are there other industries where this optimization stuff is really important?
Totally. Finance is another big one. Quantum computers could be used to develop better financial models, optimize investment strategies, manage risk more effectively.
So we're talking about potentially changing how financial markets actually work.
Exactly. Quantum computing could have a big impact on the financial industry, leading to more efficient and maybe even more stable markets.
Okay, so we've covered medicine, climate modeling, logistics, finance.
Yeah.
Are there any other areas where quantum computing could make a real difference?
There are so many, it's hard to keep track. But one that's really interesting is materials science.
Oh, right.
Ugh.
You mentioned before that quantum simulations could help us discover totally new materials.
Yeah, it all comes down to being able to simulate quantum systems, which is really hard for regular computers.
Yeah.
But by simulating how atoms and molecules interact at the quantum level, researchers could design materials with specific properties,
Right.
like superconductivity or extreme strength.
So it's like having a virtual laboratory where you can play around with different combinations of atoms and molecules to create materials with properties that have never existed before.
Exactly. That could lead to breakthroughs in all sorts of industries, the electronics, energy, transportation, construction.
Wow.
Imagine solar panels that are way more efficient or batteries that can store tons more energy.
Those would be game changers for sure. But before we get too carried away with all these possibilities, we need to remember that quantum computing is still pretty new.
Right.
What are some of the biggest challenges that researchers are still facing as they try to develop these powerful machines?
Well, you're right. While Willow is a big step forward, there's still a lot to do.
Yeah.
One of the biggest hurdles is still quantum error correction.
Okay.
We talked about how sensitive those qubits are to noise and interference.
Right.
And managing those errors gets even harder as we try to build bigger and more complex quantum computers.
Right. It's like that house of cards analogy. The more cards you add, the more likely it is to fall apart.
Exactly. So researchers are always working on new techniques to improve error correction and make these quantum computers more reliable.
What about the cost and complexity of building these machines? Are those still big barriers?
Absolutely. Quantum computers need special equipment, really low temperatures, and people who know how to use them.
Right.
That's not like we'll all have them in our homes anytime soon.
So accessibility is still a major issue. But even with these challenges, the progress in quantum computing is pretty remarkable. What are some of the breakthroughs that you're most excited about?
Well, besides the advances in error correction that we already talked about, I'm really excited about the development of new quantum algorithms.
What are quantum algorithms, and why are they so important?
Quantum algorithms are basically instructions that tell a quantum computer what to do.
Yeah.
They're designed to take advantage of the unique things quantum computers can do,
Right.
like superposition and entanglement, to solve problems that regular computers just can't handle.
So it's like writing software for a completely different kind of machine.
Exactly. And these quantum algorithms could revolutionize all kinds of fields. Drug discovery materials, science, cryptography.
Cryptography. What does quantum computing have to do with cryptography?
That's a really interesting topic. It deserves its own deep dive.
Yeah.
Basically, the encryption algorithms we use now to protect our online data are based on math problems that are hard for regular computers to solve. But a powerful enough quantum computer could potentially break those codes,
Oh, no.
making all our sensitive information vulnerable.
So are we all going to get hacked by quantum computers?
Not necessarily. Researchers are already working on new encryption methods that are designed to be resistant to quantum attacks.
Okay.
It's like an arms race between the code makers and the code breakers, but with much higher stakes.
It sounds like we're entering a whole new world of cybersecurity.
We are, and quantum computing is a big part of it. It's both a potential threat to our current security systems and a potential solution for creating even more secure systems in the future.
This is all really fascinating, but I gotta admit my brain is a little overloaded.
I know what you mean. It's a lot to take in.
Maybe we should take a break and let all this information sink in for a bit.
Yeah, that's a good idea. Quantum computing is a field that never stops. There's always something new and groundbreaking happening.
Okay, I think I'm back online. My quantum circuits have recharged.
Good to hear it. Before we got sidetracked by cryptography, you were about to tell me about the breakthroughs that you're most excited about.
Oh, right. Well, there's so many. But one area that I'm really into is quantum sensors.
Quantum sensors, what are those?
Imagine a sensor that's so sensitive it can detect tiny gravitational waves passing through space.
Okay.
Or a medical scanner that can image individual molecules inside you. That's the kind of stuff quantum sensors could do.
That's pretty wild. How do they even work?
They use the weird rules of quantum mechanics to achieve a level of sensitivity and precision that normal sensors just can't match.
Okay.
Like some quantum sensors use entangled particles to measure tiny changes in magnetic fields.
I'm getting a little lost in the quantum weeds here. Can you give me a real-world example of how these quantum sensors could actually be used?
Sure. Medical imaging is a good one. Imagine a brain scanner that could spot the very early signs of Alzheimer's,
Okay.
or a heart monitor that could predict a heart attack before it happens.
Wow, so we're not just talking about diagnosing diseases more accurately, but actually preventing them.
Exactly. And it goes beyond medicine, too. Quantum sensors could revolutionize navigation, environmental monitoring, space exploration.
Speaking of space exploration, I read that some scientists think quantum computers could solve one of the biggest challenges of space travel, communicating over vast distances.
That's right. One of the big limits of normal communication is the speed of light.
Yeah.
It takes time for signals to travel through space. So real-time communication is really tough.
Right.
But quantum communication could potentially get around that.
Wait, faster than the speed of light? I thought that was impossible.
It's not about going faster than light. It's about using this thing called quantum entanglement.
Okay.
When two particles are entangled, it doesn't matter how far apart they are, they're still connected.
Okay.
If you change one particle, it instantly affects the other one, even if they're miles away.
That sounds like something out of Star Trek. But how could we actually use entanglement for communication?
It's still early days, but the idea is to use these entangled particles to transmit information instantly, no matter how far apart they are.
So we could have real-time conversations with astronauts on Mars.
Yeah, or even further out in the solar system. It would completely change space exploration.
This is all mind-blowing.
It really is. Quantum computing is changing what we thought was possible.
Yeah.
As we talk about all this, it's important to remember that it's not just about the technology itself.
Right.
It's also about us.
Right.
How do we make sure we use this powerful technology for good?
That's a great point. It's up to us to make sure quantum computing is developed and used in a way that benefits all of humanity.
Well said. I think that's a perfect place to wrap things up for now. Quantum computing is a pretty powerful tool, right?
Yeah.
And like any tool, it can be used for good or for not so good purposes.
Right.
So as we wrap up this deep dive, I'd love to get your thoughts on the potential impact of quantum computing on AI.
Oh, that's a good one.
Yeah.
It's definitely something that a lot of people are talking about. AI relies a lot on pattern recognition and problem solving, right?
Right.
And those are things that quantum computers are really good at.
So could we see quantum computers like turbocharging AI development?
It's definitely possible. Quantum computers could analyze huge amounts of data and find patterns that traditional computers would miss,
Okay.
potentially leading to AI systems that are way more sophisticated and powerful.
What are some examples of how this quantum-powered AI could be used?
Imagine AI that could predict and help us deal with climate change.
Okay.
Or develop new sources of clean energy.
Yeah.
Or AI that could personalize education and healthcare to meet each person's individual needs.
Those are some pretty big goals. But as AI becomes more powerful, aren't we running the risk of it becoming uncontrollable or even dangerous?
That's a valid concern and one that we need to think about carefully.
Yeah.
The key is to make sure that AI development is guided by human values and ethics. We need to build in safeguards to prevent unintended consequences.
I've heard some people worry about AI becoming too intelligent and maybe even posing a threat to humanity. What are your thoughts on that?
It's a complex issue, and there are a lot of different opinions on it. I believe that AI development should be a collaborative effort between humans and machines.
Okay,
We need to make sure that AI remains a tool that we control and use for the benefit of society.
that makes sense. It's about finding that balance between using the power of AI while making sure it aligns with our values and goals.
Exactly. It's about using AI to enhance human intelligence and help us solve some of the world's toughest problems while being aware of the potential risks.
We've talked a lot about the potential uses of quantum computing,
Yeah.
but one area that really caught my eye was the idea that it could be used to simulate consciousness.
Oh, wow.
Is that even remotely possible?
That's a question that scientists and philosophers have been debating for centuries. It
Yeah.
gets to the core of what consciousness actually is and whether it can be created artificially.
So what are the arguments for and against the possibility of simulating consciousness with a quantum computer?
Some people think that consciousness is an emergent property of complex systems,
Yeah.
meaning that if we could simulate the brain accurately enough, consciousness might just arise from that simulation.
Okay.
It's like creating a virtual ecosystem.
Okay.
You don't program each individual organism, you just create the right environment and life emerges on its own.
So it's more about creating the right conditions for consciousness to appear rather than trying to program it directly.
Yeah, that's one way to look at it. Others argue that consciousness requires something more than just computation,
Okay.
some fundamental aspect of reality that we don't fully understand yet. Maybe something connected to quantum mechanics itself?
It sounds like we're still a long way from a definitive answer.
We are. Until we truly understand what consciousness is, it's hard to say for sure whether we can create it in a machine.
It's definitely a fascinating question to think about. And it shows just how significant this technology could be. So as we wrap up our deep dive into Google's Willow chip, I want to thank you for taking us on this journey through this amazing and complex world.
It's been my pleasure.
This deep dive has given us so much to think about, from revolutionizing medicine and tackling climate change to maybe even changing how we understand consciousness. The possibilities seem endless.
They really do. And we've only just scratched the surface of what quantum computing can achieve.
It's an exciting time to be alive. We're witnessing the beginning of a whole new technological era. Thanks for joining us on this journey, and we'll see you next time for another deep dive into the incredible world of science and technology.